Barry. Right now I demo my final project for blockchain. Alright, so to start with, we should run our blockchain 06688 and 16AI and 6690. Alright, so right now you can see they are not starting yet because I haven't. So right now I can make a get request on star. So let's start a miner. Yeah, so as you can see, they right now send a heartbeat to each other. And let's run our front end. Yeah, cool. And start our client. So right now, what's happening is our client is talking to our miner, and pretty much it. And our client is listening on port 8080. So yeah, I can open my that YAWT. So what I do is you can post a business and comment on that specific business. For example, when I submit the business. I go to the main page. Oh, not main page. Home page. You can see I just post a new business which is KO Ramming, and the location is San Francisco and the tag is ramming. And I can rate on that specific business. For example, I want to give it a rating of 4 and a comment like not too bad. And submit it. Oh yeah. Then I can manually go to my homepage and click the KO Ramming. You see, I already have a comment. And back to my homepage. Maybe I can give a 5-star and a comment good. Yeah. Not too bad. Yeah. Yeah, it's a good post. Yeah. So rating is fine and comment is good. So what happened is in the front end, when you post a business or post a review, they will make a transaction, and this transaction will add to the will send to the miner, and the miner will add it into its own transaction pool, and miner will add to its own transaction pool and trying to solve the proof of work. And once the miner solves the proof of work, they pull a transaction from the transaction pool and make a new block and forward the block to all its peers. So we can see, yeah. So why do I do this? Do this application? So in the current day, restaurant in YAWT may generate fake reviews in order to have good rating in YAWT to attract more customers. In order to prevent this to happen, YAWT developed algorithms to filter the fake reviews, which cause a heated controversy. Whereas all the ratings are stored in YAWT database, and YAWT can manipulate the data very easily for their interest. Therefore, this project, this decentralized rating system based on blockchain, is not controlled by any entity, and all the review, once you made the review can never change. So pretty much it. So let's look at how I implement the project. So I separated that YAWT as 3 layers: data storage, model, and the view. So the view basically is the client. The client can post a review, post a business, read businesses, and read the reviews. So here are some example. So once the client made a post request, they will trigger this function, the post business. So basically the client will make a transaction over here and broadcast the transaction to all its peers. So in this case, the client will send to these 3 miners, and these 3 miners will add the transaction to its own pool, on its own transaction pool. Yeah, that's how I implement the broadcast transaction. You see, for all the address in the peer map, I make a post request on new transaction, and this new transaction basically is that function. So the miner will listen to the new transaction, and once anybody sends a transaction over the miner will add the specific transaction into the transaction pool. And the miner also do another thing is keep trying to solve the problem. So over here you can see once the client will go inside of the for loop, and once they have a solid valid proof of so once they have a valid result and proof that they already solved the problem, they will go over here and create a new block. Here, create a new block and and create a new heartbeat and insert the new block into its local blockchain and forward the new created block as a heartbeat data. Yeah, and other miner, once receive the heartbeat data, they need to verify whether the block is solid, is valid. If that is valid, they add to its own blockchain, so on and so forth. So yeah, pretty much it. And how did I design the transaction and transaction pool? Is that for transaction, I made the transaction can easily convert it into a block and can easily convert all the information inside of the transaction into an MPT. And the transaction pool, I use queue and a mutex so that no two threads can interleave each other. So pretty much add transaction, just offer a transaction into the queue, and pull transaction is put like you pull an element from the queue. Yeah, that's for write on the data storage and write to the blockchain. So how to read from the blockchain? Yeah, it's so basically I implement the function in blockchain query.go. For example, how do I list all the businesses over here? I create 2 KO rhyming and location statistical text rhyming. So how do I get this data? So basically I traverse the blockchain and check the blockchain type. And I find that if the blockchain type is equals to business, then I know the specific block contains a business. So I append the business to its result and I return it. So yeah, all the read operation time complexities are big O for now. So for this project, I have businesses which contains username, location, tag ID, and tag type, and review, which contains user ID, business IDs, rating, comments, type. So for this project, you can add a business, you can post a business, and you can post a review for a specific business, and you can read the review for a specific business, and you can read all the businesses. So also I also implement a RESTful API based on that, and trying to separate the backend like using RESTful API and the front end calling the backend RESTful API. But due to the time limitation, I am not able to do that. But I also have a version for the RESTful API. So for example, if I just run to node for the simplicity, oops. For the simplicity, and I start the miner and start a client, and for example, I can post this business post request. Oh, I did that. I did not have that currently. Yeah, so cool. So refresh it and submit. So as you can see, once I yeah, pretty weird. Yeah. Alright, so once I submit the KO rhyming, it will show here. It will show in here. And I can click the KO rhyming. You find nothing, not reviewed yet. We do not have any review yet. But when I submit the rating 5, comment good. Alright. And click the KO rhyming. Yeah, pretty weird part. Anyway. Submit it once again. Click the KO rhyming. Oh, you can see the rating is fine, comment is good. And if you're not very happy about the launch, you wanna get it a bad review, alright? Rating is 1, comment is bad. You see, rating is 1, comment is bad. And also you can post another business like a burger king, San Francisco tag burger. I think it's because the latency. Yeah, they are trying to solve the problem. Before you solve the problem, there's no data to show. Yeah. Burger. Yeah. Go to the home page. Find running. Oh, Burger King here. Yeah. I guess they have some latency really. Yeah. So I love Burger King. So I find that there's no rating yet. So I decide to rate Burger King 5 star. My comment is very good. And submit it. Okay, Burger King, nothing shows up yet. Burger King, maybe we should wait 2 seconds. Make another request. Okay, so Burger King, oh, 5 star, very good. Alright, pretty much it. Thank you for your time. That is my Yao distributing review system. Hope you will love it. That's awesome. Thank you.